Model reflection in generative AI refers to the ability of an AI model to introspectively evaluate its outputs and performance, identifying successes and areas for improvement systematically. This mechanism supports continuous learning and adaptive responses, enhancing model efficacy over time. Implementing reflection mechanisms allows the systems to monitor their generative processes, self-assess accuracy, and dynamically refine or correct their outputs, thus significantly improving the overall quality and reliability of AI solutions. Model reflection aligns seamlessly with the systematic feedback loops previously established in AI model evaluation, optimizing accuracy and context relevance. In Azure AI solutions, implementing model reflection enhances system robustness, accuracy, and reliability by autonomously scrutinizing model outputs. It complements other Azure features like Azure OpenAI Service, Azure AI Foundry, and Prompt Flow by incorporating self-monitoring and adaptive capabilities into the model's lifecycle. Reflective models can automatically adjust to identified anomalies, improve response specificity based on user interactions, and ensure consistency in output quality. This capability is especially critical in managing the scalability and adaptive resource allocation of Azure AI services, bolstering productivity and efficiency in enterprise or user-facing applications. Reflection mechanisms usually involve iterative feedback methods where the AI output is evaluated against predefined criteria or learned assessment patterns. Typically, model reflection includes self-generated evaluation prompts, internal consistency checks and responses, external criteria, user-defined metrics. Using Azure, reflective models leverage Azure Monitor and AI diagnostic tools integrated into the Azure AI Foundry ecosystem. Reflection feedback loops closely integrate with Azure OpenAI Service APIs, enhancing models' ability to reassess and correct outputs actively. This self-refinement dynamically adjusts generative outputs, aligning closely with evolving user requirements and expectations. Implementing model reflection involves several clear, structured steps. 1. Defining explicit evaluation criteria and metrics. 2. Integrating feedback mechanisms within model output processes. 3. Implementing self-assessment prompts using Azure OpenAI. 4. Using diagnostic data analytics, Azure Monitor, to assess outputs. 5. Refining models based on feedback loops for continuous performance enhancement. Each step demands rigorous planning, execution, integration with existing Azure ecosystem components, and compliance with project-specific objectives and key performance indicators, KPIs, ensuring alignment with the holistic generative AI solution architecture. Azure AI Foundry simplifies the integration of reflection mechanisms by offering pre-built tools and resources optimized for model development cycles. These tools include configurational options for prompt flow design and straightforward feedback loop implementation, facilitating reflection without extensive coding efforts. With Azure AI Foundry, users can easily define and modify reflection criteria, seamlessly integrate reflection into existing AI lifecycle phases, leverage internal resources for systematic feedback aggregation. Its unified environment ensures that reflective capabilities improve iterative refinement efficiently within completed generative AI deployments. Prompt flows are instrumental frameworks within reflective generative AI, responsible for systematically directing reflection processes via prompt sequences. When implemented effectively in Azure, prompt flows can drive introspection, analyzing output coherence, logic, and contextual accuracy. To integrate reflection within prompt flows, craft systematic reflection-oriented prompts. Ensure prompt outputs explicitly solicit reflective assessments. Evaluate responses using subsequent reflection-focused prompts. The synergy between prompt flow design and reflection significantly enhances the sophistication and accuracy of generative model outputs, optimizing the relevance and practical usability of AI-generated content. Reflection prompts guide AI models in conducting self-assessment by clearly stating objectives, expectations, and evaluation criteria. Effective reflection prompts typically include direct questions about the rationale, accuracy, and completeness of the generated output, requests to assess consistency with prior responses or external knowledge bases, commands to evaluate potential biases and logical inconsistencies explicitly. Proper implementation involves formative iteration, evaluating prompt responses, and revising reflection prompts to ensure they comprehensively address evaluation objectives. Utilizing Azure's prompt management tools can streamline prompt creation, testing, and deployment, embedding robust reflective capacities iteratively within model operations. Evaluating reflective model outputs requires comprehensive metrics spanning accuracy, relevance, consistency, and logical coherence in self-assessments. Central evaluation strategies involve quantitative scoring based on predefined benchmarks or ground truths, qualitative analysis comparing reflective feedback to actual performance, user-driven qualitative feedback gathering via interactive Azure interfaces. Azure Monitor and Prompt diagnostic tools serve to analyze reflective outputs systematically. These evaluations support iterative enhancements in reflection mechanisms, guiding further tuning of generative behaviors for increased reliability and accuracy. Azure provides robust tools for diagnosing and refining reflective model behavior. Azure Monitor collects detailed diagnostics and performance data, enabling systematic assessments of reflective processes through metrics like response accuracy, processing latency, and consistency in model self-assessment. Key Azure monitoring aspects include tracking reflection prompts efficacy, reporting on reflection process impact on accuracy, diagnostic assessments identifying anomalies and outliers, utilizing built-in monitoring capabilities alongside customized diagnostic tracing enables precise control and continuous enhancement in reflective modeling approaches, maintaining high-quality generative outcomes. Optimizing reflection implementations in generative AI involves several best practices, clearly defining reflection objectives aligned with business goals, systematically structuring reflection feedback loops within Azure environments, continuously refining reflection prompts and assessment criteria, iteratively evaluating reflection effectiveness using comprehensive Azure diagnostic data. Adherence to these practices ensures robust, effective reflective mechanisms, enhancing generative models' adaptability, accuracy, and reliability within complex, dynamic operational contexts. Implementing model reflection presents unique challenges, including defining sophisticated, accurate self-assessment criteria, balancing reflection frequency with resource allocation efficiency, addressing complexity in reflective outputs integration, avoiding self-assessment biases or myopic reflection, focusing only on explicit criteria. To mitigate challenges, it is crucial to regularly revisit and refine reflection strategies, implement scalable reflective methods, and leverage Azure AI Foundry's extensive supportive tools designed specifically for streamlined feedback integrations and iterative reflection improvements. Continuous learning significantly benefits from robust reflection mechanisms, allowing models to dynamically integrate new insights and adaptively modify performance based on reflective self-assessment. Reflection catalyzes iterative improvements, fine-tuning models progressively in response to encountered scenarios, evolving contextual requirements, and feedback from end-user interactions. The implementation of reflection-driven continuous learning within Azure involves combining Azure AI Foundry tools, Azure OpenAI API capabilities, and Azure's powerful monitoring facilities. Together, these resources deliver scalable, continuous learning capabilities vital for maintaining generative AI solutions' exceptional long-term efficacy and relevance.